solve a question under linear momentum involving the change in kinetic energy, or rather the loss in kinetic energy of a moving particle. So the question goes like this. They are saying a particle of mass m moving with a velocity which is labeled with letter u makes head-on elastic collision with a particle of mass 2m initially at rest. Show that the particle of mass m loses 8/9 of its initial kinetic energy. So this question, a simple interpretation that we can give over the same question has to be something like this. So I'm going to draw the same two different balls. We have this and that one. So this one you can label it as ball A, and that one I'll label it as my ball B. So they're saying this ball, the initial velocity for this one is given with a letter U. The initial velocity for this one has to be equal to 0. Why? Because it is initially at rest. So this is for ball A. So since they're saying we have to find the loss in kinetic energy for this ball, meaning that I'll only concentrate on this particular ball. So here they're saying the type of collision which is taking place here is what we call elastic collision. What does it mean? This actually means that kinetic energy and linear momentum are both conserved. So linear momentum and kinetic energy are conserved. Now what does it mean? If you hear something like elastic collision and something is taking place in a linear form without making angles, automatically you can either use linear momentum and kinetic energy, or there is another quantity which is very, very important. They call it coefficient of restitution. What does it mean actually? You are going to understand that if you are using this and that one, still you are going to get the same answer if you use this and that one. So as for me, I prefer using this and that one to this and that one. Hence, it is going to be like this. So initially, since this is moving, meaning that its initial kinetic energy has to be equal to what? Has to be equal to 1/2. We are talking about this one which is having a mass of m. This one they're saying it is having a mass of 2m. Definitely, it means the initial kinetic energy of this particle with reference to the initial kinetic, the initial velocity, is going to be m multiplied by u squared. This is the initial kinetic energy of this given particle. So we have now to find its its final kinetic energy for me to come up with what? The change with respect to the same what? The same initial kinetic energy. That's how we find the loss. So you say loss in kinetic energy of particle A has to be equal to, I'll say kinetic loss. Since we're talking about out of its initial, definitely it has to be something like this. You say initial minus final, you divide now throughout by what? K initial. Why? Because they're saying the loss of kinetic energy due to what? Or with respect to the initial kinetic energy of this same particle. Okay, now what next exactly? What are you supposed to do next for you to find the final kinetic energy of ball A? So what we are going to do next is this. Here I'm from saying linear momentum and kinetic energy are conserved, meaning that I'll start by finding the linear momentum for these two different balls. But you have to be very careful because this particle or this ball is actually at rest, meaning that once they collide, it will only have what we call the final velocity, or rather the final linear momentum. So I'll say using linear momentum. Okay, so whenever I try to use linear momentum, what exactly am I going to take or am I going to get? So you say the summation of initial momentum must be equal to the summation of final momentum. Okay, so what next now? Here, the meaning of summation will mean you have to find the momentum for this as well as that one. So I'll say mass A. By the way, I can just label the final velocity for this one as VA. The final velocity for that one, I'll label it as VB. And like using my prime, you might end up getting confused. So I'll say MA multiplied by the initial velocity of particle A plus MB multiplied by the initial velocity of particle B, you say equal to, you're going to say MA multiplied by the final velocity of particle A. Now say plus, okay, so I'm going to say plus MB multiplied by the final velocity of particle B. Now, what are we supposed to do next once you reach at this given point? Be careful, because here they're saying this one initially it is at rest, meaning that if this particle B is at rest, definitely we are going to get its initial momentum as what? As 0. Why? Because the velocity is going to be equal to 0. Okay, we proceed. So we are going to find that we are going to have what is the mass of this one, which is going to be M, and the initial velocity for particle A, or particle A they're saying is what? U. Then you understand that it will be MU has to be equal to, here you're going to have M because that is the mass of ball M. Then you're going to have A plus the mass of this ball initially, which has been given is what? 2M. Then you replace it here, you say 2mVb. Now where we are, what does it mean exactly? This actually means that you're going to cancel out this, that, and the M in between 2 and VB. Definitely we are going to come up with the first equation, which is going to be equal to VA plus 2VB. This becomes my first equation. I'll label it as my equation 1. Okay, now we proceed. What are we supposed to do next once we proceed? Here you are going to understand it fully to say, using the principle of coefficient of restitution, we are going to understand that this one, the way it works like this. Since we have this particle which is initially moving, meaning that you are going to start with the same particle which is what? Moving. You say VA, then you say that is the final velocity of particle particle A. You say VB. Same applies on the part of the initial velocities for each. So since this type of collision is what we call elastic collision, automatically the value of E has to be equal to 1 for elastic collision. So this formula goes like this. You say V initial of A minus V initial of B. This has to be equal to what? Negative E. We are saying if this type of collision is what we call elastic collision, automatically the value of E here has to be equal to 1. Has to be equal to 1. So you say E has to be equal to 1 for elastic collision, like this. So what does it mean? What exactly are you supposed to do next? You understand that what you're going to do next, I'll just flip this page so that I can write on a proper page. Alright, now having said that E has to be equal to 1, how is the entire formula now going to be? So we are saying VA minus VB over VA. Sorry, this has to be initial of A minus V initial of B. This has to be equal to negative. So since here I'm from saying to say the value of E has to be 1 if the type of collision is equal, the type of collision is what we call elastic. For inelastic, the value of E has to be equal to what? 0. So since we are dealing with elastic collision, like the way question said, we are going to have -1 for coefficient of restitution. So we understand that the initial velocity for this one is u, and this one, since it is at rest, automatically to have an initial velocity of 0. Definitely we are going to have v a minus v b. You divide here by u minus 0, you're going to get -1. So if you multiply this and that one, you have to divide to have a placeholder there. You multiply and you get v a minus v b has to be equal to -u. This becomes my second equation. Remember, we are only dealing with the ball A. Why? Because it is the one which is losing its kinetic energy as it is colliding with the ball which is at rest. So what are we supposed to do next? Now this is going to be my second equation. I'm going to have equation 1 and 2. Then I have to make sure that I only appear with the initial velocity of A and what is the final velocity of ball A. What exactly is it going to take it like for us to come up with such a thing? Automatically what we are going to do here, we are going to make, before I do that, sorry, I'll have my u equal to VA plus 2 VP, which is my first equation for what? For linear momentum that we used. Now we are using coefficient of restitution. We are going to have VA minus VB, giving us what? -u. This is my second equation. So our main aim is to make sure that this VB disappears so that I can come up with the final velocity of the first ball. What are we supposed to do? Okay, so we are going to solve simultaneously the first equation and the second equation. How possible is that? I'll just make this the subject of formula and replace where there is that in the what? In the first equation. So if I make this as a subject of formula, I'll just make it move to that other side, and this one will come and replace its what? Its place. You will find that this is going to be VA plus U is going to be equal to what? VB. This becomes my third equation. Now you have to make sure that this, you replace it where there is what? VB in the first equation. So I'll say replace VB by VA plus U in the first equation. Okay, move a bit. So we are going to understand that it will be like this now. If you take this and you place there, you are going to come up with something like U equal to VA plus 2 open VA plus U. So you understand that it will be U equal to VA plus 2 VA plus 2 U. If you add these two, what answer are we going to get? And if you take this to the other side, it will be U minus 2U going to be equal to 3 VA. You divide throughout now by 3, even here by 3. You understand that VA, which is the final velocity of ball A, is going to be equal to what? -U over 3. This becomes the final velocity, meaning that I will find the final kinetic energy using the same what? Final velocity of ball A. Okay, what is the formula that we are going to use for us to come up with the final velocity now? I mean the final kinetic energy of ball A. So here I'll write it like this. I'll say K final, it has to be equal to 1 over 2 m VA square, because I'm dealing with the final velocity of what? Ball A. This is the only ball which is losing its kinetic energy. That's why we're focusing on it and not for ball B. What is it that we're going to have? We're going to have K final equal to 1 over 2 m. If you get back to this, you understand that you are having VA as equal to that. You replace in the equation there. We are going to have -U over 3 square, and you have K final just to be equal to 1 over 2 m U square over 9, meaning that the final kinetic energy for ball A has to be equal to 1 over 18 mu square. Remember the formula, what it says. We are saying the loss of kinetic energy for ball A due to its initial velocity, we have to do what? It is going to be like this, loss. And remember, we wrote the formula for kinetic loss as follows. I wrote something like this. This is the formula we are going to do what? We are going to use. So we say this has to be equal to K initial loss. It means you start with the initial. It is different from change in kinetic energy and the like. So we're going to subtract this by K final over K initial. Why? Because they're saying due to its initial kinetic energy. We have this as the final kinetic energy, and also the other one which is here from finding, I found it at first, this one, meaning that this is going to be like this. You say K loss, it has to be equal to, what is my initial kinetic energy? We are saying it has to be 2 mu square minus 1 over 18 mu square. You divide by the initial kinetic energy, which is 1 over 2 mu square. The simplest way of doing this, you know that this is 1 over 2 mu square. Even here, you can just factor out this because this can also go into that. Actually, we are going to get the kinetic loss as equal to, okay, we're going to have 1 over 2, you say mu square, open bracket. What are you going to remain with here? You have 1 minus here, it will be 1 over 9. Then you divide this by what? By 1 over 2 mu square. Meaning that K loss, which is kinetic loss, must be equal to this, and that will go. If you subtract here, you're going to understand that it will give you automatically the answer, which is 8 over 9. Then you say hence shown. So these are sessional questions. If you get something like this, automatically you are deserving your entire 10 marks. Thank you for watching.